In this video, I will introduce you all parameters of TEtrimmer. I also highly recommend you to watch the other two videos about TEtrimmer background introduction and how to use TEtrimmer GUI, because those two videos will also help you to understand the parameters of TEtrimmer. In general, TEtrimmer provides 34 parameters. To balance the flexibility and usability, we have established thoroughly tested default setting for all the parameters, which has been optimized across a wide range of eukaryotic genomes to ensure a robust performance without needs for modification. But in order to help user to understand and modify parameters for their own purpose, I provide this tutorial video. I will not cover all the parameters because some of them are easy to be interpreted. For example, the continual analysis can allow the user to continue the previous unfinished TEtrimmer results. I will only cover the parameters with different backgrounds, and basically parameters can be grouped based on their functionality. For instance, declassification, deduplication, Blazon search, multiple six element clustering, extension, cleaning, and the T-boundary definition. So later I will introduce them one by one. The first is related to T classification. It includes classify unknown and classify all. TEtrimmer uses repeat modular classification module. It's called repeat classifier for T classification. This is the code used for the classification. Classify unknown will use repeat classifier to classify the consistent sequence if the input sequence is not classified, like this, or it is unknown before the hashtag the classification is unknown, or the query T sequence extended more than 3000 base pairs. Because when the extension is too long, it means the processed T sequence can be highly different with the initial input sequence, so TEtrimmer gonna use repeat classify to classify the sequence again. If the user uses classify all, the repeat classifier will classify every considered sequence. But please be aware this might take a long time, could be computational resource intensive. For example, this is one input sequence, and before the hashtag this is one DNA element. So after the curation of TEtrimmer will run repeat classifier on this sequence again. So if the output from repeat classifier is different with the previous or the initial classification, for example, after the repeat classifier is then classified at LTR, then the LTR classification will replace the initial classification. But of course, it could happen the repeat classifier cannot give a classification, then TEtrimmer is going to use the initial classification name. So in summary, TEtrimmer will, by default, TEtrimmer will not use repeat classifier at all. But if you add classify all, it will run repeat classifier on all analysis or curated T sequence. If you add classify unknown, it will only apply repeat classifier on sequence which do not have initial T classification, like this and that. And also, it will on analysis run the repeat classifier on the sequence that the multiple six alignment extension is long enough. After T classification, I want to introduce parameters about TE deduplication. It includes dedupe and the curated lab. So dedupe parameter remove highly similar sequence from the input file. So this is the corresponds command code. It uses cd head for this purpose. Here is how it works. So suppose in your input sequence, the sequence in your input file contains 3 T sequence that can be aligned. And the sequence 1 is the longest sequence. So sequence 2 and the sequence 3 will be compared against the sequence 1. So if the aligned region between the sequence, when compare sequence 2 to sequence 1, if the aligned region, these parts, occupy more than 95% of sequence 1 and sequence 2, and alignment identity is more than 90%, then the sequence 2 will be removed. They'll follow the same logic, then sequence 3 will be compared to the sequence 1. Because aligned region only occupy more than 95% of the sequence 3, not sequence 1. So the sequence 3 will be kept for further analysis. Because the sequence 1 could be a necessity. If we remove the sequence 3 directly, it can lower the TE discovery sensitivity. So after dedupe, only sequence 1 and the sequence 3 are going to be used for further analysis. Please be aware, so use dedupe, this parameter can accelerate your TE analysis. For example, this will remove the sequence 2, but this can also reduce the sensitivity for TE discovery, even though the filtering criteria is quite stringent. Curate lab is designed with different purpose comparing to dedupe. Behind this parameter, you need to provide manually curated TE consistency library for this parameter. So you assume some TE sequence from the input file, this is a sequence from the input file, and this is one sequence from the curated lab, that's a manually curated library. This one sequence from your manually curated library. You assume some sequence from your input file that they are identical or highly similar to those sequences in the manually curated library. So there's no need to process those sequences with TEtrimmer again. The curated lab option allows you to eliminate those redundant sequences from the input file based on the similarity to the curated library. So for instance, there is a 3 sequence from the input file that can be aligned to the sequence from the curated library. When comparing sequence 1 to the sequence from the curated library, they can very nicely align with each other with more than 95% identity. At the same time, the aligned region occupy more than 95% of sequence 1. Then sequence 1 will be removed. Then come to sequence 2. So the aligned region occupying more than 95% of the sequence 2, then sequence 2 will be removed. So this is the difference between the curated lab to the dedupe parameter. So the dedupe parameter requires aligned region more than 95% in the sequence 3 and the sequence 1 simultaneously, but in the curated lab, because we assume your input manually curated library is with very high quality, there's no necessity. So the only required aligned region occupy more than 95% of the shorter sequence in the sequence 2. Then the sequence 2 will be also eliminated from the input file. Then even comparing sequence 3 with the sequence from the curated lab, even they can very nicely align, but aligned region only occupy probably half of the intact sequence of the sequence 3, then the sequence 3 will be kept for further analysis. For this, please make sure you provided manually curated TE consistency library with very high quality. I think this parameter, or this option is very useful for the pan-genome analysis. For example, you have 10 genomes from one species, and you already have done one manual curation, or you have applied TEtrimmer on one genome. It's not necessary that you do de novo, to do de novo T annotation and then to run TEtrimmer for the rest of the genome. Then you can use the manually curated library from the first genome and add to behind this parameter and to reduce the workload for your analysis. So next, I will talk about those 4 parameters, including genome annotation for the whole genome deannotation, for debugging, and PFAM domain prediction and consensus generation. So first is the genome anno. It's called the genome annotation, whole genome T annotation. So when you add the genome anno, this parameter in your code, the TEtrimmer will do whole genome T annotation with the repeat mask. This is the code based on the TEtrimmer curated TE library. So this is the command, and please be aware, so this step can be potentially take long runtime based on the size of the curated library size, curated library, and also the genome size. So this is the debug parameter. So this parameter can allow you to turn on the debugging mode of TEtrimmer. By default, it's off, which means when you after finish the run TEtrimmer, then in this menu, multiple sequence alignments, this folder is empty. But when you add this parameter after the analysis, the many files will be found under the multiple sequence alignment folder. So this is only for debugging purpose. Please note, using debug option might require much more storage space for your outputs. So TEtrimmer uses PFAM database to predict the TE associate TE protein domains. You can use PFAM directory to provide your own PFAM domain or provide a path that allows TEtrimmer to download the PFAM domain. So if the PFAM directory, this parameter, is not specified, is not used at all, TEtrimmer will automatically download the PFAM database to the source code directory of the TEtrimmer when it is run on the first time. So alternatively, you can provide a local path. Then TEtrimmer will check the existence of the PFAM domain, the PFAM database in your provided directory. If TEtrimmer finds it, then you're going to use it. Otherwise, it will automatically download PFAM domain to your provided path. Of course, the automatic downloading can be failed due to the issues such as the unstable internet connection. In such case, TEtrimmer will print the detailed instruction like this in the terminal to guide you how to manually download and configure the PFAM database. For example, it will tell you what should be contained in the folder and how to download them and how to configure them. And for the Singularity user, please use this parameter directory, because Singularity or Aptina image is not writable. You have to download the PFAM domain outside this image. So at the final step of the TEtrimmer analysis, when it finished the boundary definition, it will generate the considered sequence based on multiple sequence alignments. The consensus threshold can define the threshold used for generating the considered sequence. For example, by default, it's 0.7, this multiple sequence alignment. This is the considered sequence. So with 0.7, which means if in each column, the nucleotide, for example, in this adenine is more than the predominant nucleotide adenine is occupy more than 70% of all the nucleotide in the column, then the corresponding consensus will be A, adenine. Otherwise, it will be N. You can slightly decrease this threshold number when you find there's so many N's in your output. So this is the consensus sequence N. This will generate consensus N when the proportion of the predominant nucleotide in column is smaller than 0.7. Now I would like to introduce some parameters related to +N search by TEtrimmer. For example, it will define what's the minimum +N search length, and it also have requirement for what's the minimum requirement for the +N hit number. If there's so many BLAST results, how to choose the top candidate for further analysis, use this maximum multiple sequence alignment lines and the top multiple sequence lines. So TEtrimmer conduct a +N search of each input T considered sequence against the respective genome to identify the query copy. So this is the corresponding command. The minimum BLAST length we'll define the minimum length, the sequence length for blast hits to be included for further analysis. For example, the default is 150. If the blast and search hit is lower than this number, then this hit will be removed from the blast readout. The minimum sequence number will define the minimum blast hit number required for the input sequence. So we do not recommend to decrease this number. Default is 10. You can increase this number to increase your TE annotation specificity. Of course, you will lower the sensitivity, but please do not lower this number. For example, if your blast N hits is lower than 10, then this sequence will be, not go for further analysis. We'll check if this is a low copy or if this is will be skipped for this sequence. Here, this example, this blast N search example. This is a query. This is the genome identity, and this is the blast search. The blast length. In the final hit, this blast length is only 90. It's lower than 150, so this blasting hit will be removed for further analysis. You can decrease this number to include a shorter blasting hit. So after blast result filtering, in this number there's around 31 blasting results left, and it's more than 10. So then those corresponding sequence will be used for example, for the analysis include the multiple switch alignments, clustering, extension, and boundary definition, and so on. Just in case, if after filtering step, there's less than 10 blasting hits, it's less than this number, then the corresponding input taken the sequence will be classified as a low copy or skipped. As for how it will be classified as low copy or skipped, please refer to our TEtrimmer paper for more details. You can, like I said before, you can increase this number to increase the TE discovery specificity, but definitely you will lower the sensitivity. We highly recommend to keep this number like this. Those are two parameters. You can also configure the blast search. There's one question. For example, if you have after blast search, there's a thousand blasting hits, what will happen? Do TEtrimmer do multiple sequence alignment for 1,000 sequence? Of course not, because that will take ages for the multiple sequence alignment. To solve this problem, TEtrimmer provides those two parameters. So the maximum multiple sequence alignment lines and the top multiple sequence alignment lines. In the example, let's say the maximum multiple sequence line set to 20 and the top multiple sequence line is set to 15. TEtrimmer will sort all the blasting hits by the last column, the blasting length, and choose the top 15 longest blasting length, because the top multiple sequence alignment line is 15. And because the maximum multiple sequence line is 20, then it will randomly choose 5 hits from the rest of results. By default, maximum multiple sequence line is 100 and top multiple sequence line is 100, which means it will sort the blasting hits by the length and then choose the top 100 longest blasting hits for further analysis. After blasting search, I will introduce the parameters related to the multiple sequence alignments clustering, the maximum cluster number. So due to the typical high sequence similarity among the T subfamilies, the multiple sequence alignments are based on the blasting search of each input T consistent sequence against the corresponding genome usually contains several subfamilies, which is displayed by the distinct alignment paths like this. So it's very important to very clearly or efficiently to cluster those to separate those multiple sequence elements. The parameter maximum cluster number is used to define how many clusters going to be used for further analysis. The default number is 5. The top 5 cluster going to be used. But on top of that, the cluster number also have to contain more than a minimum sequence number. The default number is 10 sequence, which is to say the default number is 5. In theory, the top 5 gonna be used, but the other requirement is the sequence number in each cluster have to be more than 10. In this case, only sequence cluster 1 and cluster 2 have more than 10 sequence. So only these two gonna be used for further analysis. The cluster 3 to 5 will not be used. After clustering, TEtrimmer will extend the cluster multiple sequence element to include the T boundary. So those 4 parameters are related to the extension of the multiple sequence element. For example, what's the extension step, what's the maximum extension size, and extension threshold, and the extension check window. So let's first introduce these two: extension step and the maximum extension. For example, this is one input T sequence, and after Blossom search, multiple sequence element and clustering, this is the result. In order to include the boundary for this input T sequence, you're gonna do extension for left side, left end, and right end. First is left end. So after 5 times of the extension, it finds the boundary for lowly and highly conserved region for the multiple sequence elements. You're gonna stop here, stop the extension. And then you come to the right end. After 4 times of the extension, it finds the boundary for highly and lowly conserved region in the multiple sequence element and stop here. Finish the extension. Then the question is, what's the size for each step extension? This can be defined by the extension step. By default, the extension step is 1000, which means each time extension is 1000. And then there's also a maximum extension requirement. By default, the maximum extension requirement is 7000, which means the left side or left end extension, the max can be maximally extend 7000 base pairs. So in this case, it's 5000 because it extends 5 steps. Then the total extension size is 5000 and found the boundary. In case the left side extension extends 6 times and still cannot find the boundary, then it will also stop because the maximum extension size is 7000. It's the same for the right side. Each time the extension is 1000, 1000, 1000, and 1000 until you find the boundary for the highly and lowly conserved region. And the maximum extension for the right end is also 7000 base pairs. Please be aware, this maximum extension, 7000, means for each end, for left end and right end, not the both. Now come to the question, how TEtrimmer define for the left side, 5 times extension will be enough, and for the right side, 4 extension will be enough. Then this can be defined by the other 2 parameters that I'm going to show you. So let's zoom this part, this region, the boundary part. So this is the zoomed part. This will define by TEtrimmer if after the 4th time extension for the right end, the extension is enough. This is the multiple sequence element. They will generate a consensus sequence. And the default threshold for the generating consensus sequence is 0.7. This is very similar with the parameter is called consensus threshold we talked about before, that it has with different purpose. So for the consensus threshold we talked before is to generate the consensus sequence and the final end of TEtrimmer analysis. And this extension threshold is also defined the thresholds to generate the considered sequence, but this is serve to judge if the extension is enough or not. Those are different. Please be aware about that. So, same like before, if in the predominant nucleotide in this is a thymine, it's more than 70% is a column, then the corresponding considered sequence will be thymine. Yeah. Otherwise, there will be lots of ends. So extension threshold here will define the threshold to generate the considered sequence. So after that, a sliding window is selected only for the considered sequence. Then the size of sliding window, that by default is 150, that's the sliding window will contain 150 of the nucleotides. You can define this by the extension check window, define the size. Then the sliding window will move and stop until the n included in the slide window is smaller than 30%. Then it will check the right end of slide window to the end of the multiple sequence alignment if this more than 300 base pairs. If so, then it will stop and think the extension for this side is finished. So if you think the extension, when you judge a result, you think that extension for a result is always not sufficient, not enough, then you can decrease this number to make it easier for the extension. If you think that it's always overextended, then you can higher to increase this number to make this harder to generate the considered sequence. So those are the 4 parameters related to the TE extension. Then those the gap threshold, gap nucleotide thresholds, and even the crop and divergency threshold, crop divergency window, crop and gap threshold, crop and window. Those 6 parameters is related to the multiple sequence alignment cleaning. So I introduced those 6 parameters in the other videos called TEtrimmer background introduction and TEtrimmer how to use TEtrimmer GUI. I will only briefly to introduce them, and for more detail you can go to the other 2 videos. So for removing the gappy columns, TEtrimmer will calculate the first to remove the columns that have more than 80% of the gappy the gaps. It will remove them, and then it will check the columns with the gap that is more than 40%, and but the most nucleotide is less than 70%. Is the most common or predominant nucleotide is less than 70% of the column. If then in this way it will delete this column again. So the gap thresholds can define this threshold here, and the gap nucleotide threshold can define this. For example, if you think the gappy columns cleaning is not enough, you can decrease this number. Otherwise, you can also decrease this number. And like I said, I will only briefly talk about this. Please go to the other video. It's called TEtrimmer background introduction. I introduced the principle how to remove gappy columns. Then it comes to crop and divergency thresholds. The entire multiple sequence alignment will be converted to proportion matrix. Then for each line of the matrix, it will choose a sliding window like this. Then the crop and divergency thresholds is calculated average proportion number. The crop and divergency window is defined this window this size. This can identify or to adjust the ability for multiple sequence alignment cleaning. Please go to TEtrimmer background introduction for more detail for this parameter. And then crop and gap. Then it will for each line of the multiple sequence alignment, for example, this is one line from here, it will create a sliding window, and the crop and gap thresholds it calculates the gap proportion included in this slide window, and the gap and the crop and gap window can be identified, can be used to set the size of this slide window. As for how to adjust them and send them, please read our paper and go to the other video for that. I will not spend so much time for this. Then it's come to the start pattern and the pattern. This is used for TE boundary definition. So for LTR retrotransposon, the always start size, the start size always with TG and ends with CA. This is the very common pattern. So TEtrimmer will check if the start size is start with TG, or if not, if end with CA. You can define the pattern. Of course, for different LTR, in different species, this can be different. You can set by the start parameter. If you have different the patterns, you can separate them. For example, you think they're TG, they can be TG, TA, TC. You can separate them by comma. They will check TG first, then TA, then TC. Just in case, if the initial start, the boundary definition is wrong, it's set to here. But you want to check for the pattern for TG, it will check the 10 nucleotides around the initial T boundary, defined T boundary, to check for the existence of TG and define the boundary to there. So this is the function for the start pattern and the end pattern. For the last parameter, I want to talk about the preset. By default, it's a conserved preset, and then it's a divergent. You can see the difference for the conserved and the divergent difference is considered threshold difference, and the extension abilities difference for conserved. Compared with conserved, the divergent sets have a easier tend to have a longer extension, and the maximum extension is different. So in our experience, we recommend the user to always use conserved presets and only change to divergent presets when you think that you're not satisfied with your results. Okay, great. So these are all the parameters for TEtrimmer. Many thanks for listening.